Good morning, student. In today's lecture, we discuss the specific activity. Specific activity of a substance is defined as the activity of 1 gram of a radioactive substance. Radioactive substance. That means specific activity is defined as the activity of 1 gram of radioactive substance. The activity of radioactive substance at an instant is given as activity of a radioactive substance at an instant is given as A is equal to lambda n. If capital M is the mass of substance at that instant, then the specific activity is AS is equal to activity divided by M in gram, mass in gram, right? Specific activity of radioactive substance is equal to activity divided by mass in gram. That means AS is equal to specific activity denoted by letter AS is equal to A divided by M. A is the activity, M is the mass in gram. Then AS is equal to activity means lambda n divided by capital M. Right? This is the equation number first. Then according to the Avogadro's hypothesis, the number of atoms in 1 gram of hydrogen is, according to the Avogadro's hypothesis, number of atoms in 1 gram of hydrogen, is 6.023 into 10 raised to 23 atoms, right? That means 1 gram of hydrogen मध्ये किती atoms असतात तर 6.03 into 10 raised to 23 एवढे atoms असतात. This number is called as Avogadro's number. ह्या नंबरला काय म्हटलं जातं? Avogadro's number, right? According to this hypothesis, the substance of carbon C12, the number of atoms in 12 gram of C12 is 6.023 into 10 raised to 23. This number of atoms in 1 gram of C12 is 1/12 into N naught. N naught is the Avogadro's number. Then let us we have substance of atoms. That means number of atoms in 1 gram of substance is equal to number of N naught. N naught is the Avogadro's number divided by atomic weight. That means number of atoms in 1 gram of C12 is 1/12. 12 काय आहे, ह्या कार्बनचा ॲटॉमिक नंबर आहे इंटू n naught. n naught is the Avogadro's number. Okay, where n naught is equal to 6.023 into 10 raised to 23. Okay, that means generally we have a substance of atoms. Substance of atoms जर असा असेल Z and here atomic weight, then number of atoms in 1 gram of a substance is equal to Avogadro's number divided by atomic weight of that atom, right? This is the general formula to calculating the number of atoms in 1 gram of substance. Then number of atoms in m gram of substance is हे 1 gram of substance साठी आपण कॅल्क्युलेट केलेले. तेच number of atoms in m gram of substance मध्ये किती नंबर ऑफ ॲटम्स आहे हे जर कॅल्क्युलेट करायचं असेल तर n number of atoms in m gram of substance, n is equal to n naught divided by atomic weight into this m gram of substance. Okay, where atomic weight is atomic weight of the substance. Atomic weight is the atomic weight of the substance. Then n by m, this after rearranging, is equal to n naught means 6.23 into 10 raised to 23 divided by atomic weight, right? Then specific activity As is equal to lambda into lambda n. General formula is lambda n. Specific activity As is equal to lambda n. Then this lambda n, substitute the value, then specific activity is equal to lambda into n means here. Okay, n, what is the value of n? This 6.23 into 10 raised to 23 divided by atomic weight, right? Then As is equal to, what is the lambda? Lambda means here we use the half-life formula, 0.693 divided by T into what is the this 6.023 into 10 raised to 23 divided by atomic weight. Must remember this. Then after solving this, specific activity becomes, then As is equal to lambda n, then As specific activity is equal to lambda means 0.693 divided by T using the half-life, okay, into n means 6.023 into 10 raised to 23 divided by atomic weight, right? Then specific activity As is equal to 4.174 into 10 raised to 23 divided by T into atomic weight, right? Capital T is the half-life period. Capital T is the half-life, okay, of the substance. The mass of substance corresponding to 1 curie activity. Here we discuss the mass of substance corresponding to 1 curie activity. Here capital M be the mass of substance, capital T is the half-life, then number of atoms in it is equal to number of atoms in it is equal to N naught divided by atomic weight into mass. Okay, then N is equal to capital M into what is the N naught, 6.023 into 10 raised to 23 divided by atomic weight, right? Then the activity of this substance is A is equal to lambda N, then A is equal to lambda into what is the N here, M into 6.023 into 10 raised to 23 divided by atomic weight. Then substitute the value of lambda, 0.693 divided by T into M, here 6.023 into 10 raised to 23 divided by atomic weight into capital M, right? Here activity A is equal to 1 curie, then A is equal to 3.72 into 10 raised to 10 disintegrations per second per gram, right? Then after substituting in here 3.72 into 10 raised to 10 is equal to 0.6. This equation 0.693 divided by T into 6.023 into 10 raised to 23 divided by atomic weight into M, right? Then capital M is equal to 8.864 into 10 raised to minus 14 into atomic weight into T, half-life. Then M is equal to, here half-life is taken, here T is equal to in seconds, okay? Then M is equal to 8.864 into 10 raised to minus 14 into atomic weight into capital T, right? Here T is in second. For example, here mass of 1 curie source of, इथे एक example घेऊया, example, right? Mass of 1 curie source of uranium 238 having half-life 4.5 into 10 raised to 9 years is capital M is equal to 8.864 into 10 raised to minus 14 into atomic weight into half-life in second, right? Then 8.864 into 10 raised to minus 14 into, what is the atomic weight of uranium? 238 is the atomic weight of the uranium into capital T. What is the lifetime? Half-life is 4.5 into 10 raised to 9 in year. Then we convert into second. 365 days into 24 into 60 into 60, right? Then capital M, mass of one curie source of uranium is equal to 3000 kg. After solving this, we got the mass of this 1 gram of 1 curie source of uranium is equal to 3000 kg. 3000 kg uranium will have activity equal to 3000 kg uranium 238 will have activity equal to 1 curie, right? This is the example of the specific activity. Must remember, in here we discuss the specific activity. Specific activity of a substance is defined as the activity of 1 gram of radioactive substance. Specific activity म्हणजे काय? तर specific activity म्हणजे activity of 1 gram of radioactive substance. 1 gram of radioactive substance मधली जी activity तिला आपण specific activity असं म्हणतो. तिचा जनरल फॉर्म्युला जो आहे तो इथे आपण डिराइव्ह केलेला आहे आणि त्यावरून आपण जे मास आहे 1 क्युरी मध्ये mass of 1 curie, okay, source of any atom, that will be calculated. Okay, understand this concept, specific activity. Okay, next point is the successive disintegration. In here, this is very interesting point. Successive disintegration. We know the original radioactive atom called as parent atom. त्याला आपण काय म्हणतो? पॅरेंट ॲटम असं म्हणतो. म्हणजे जो ओरिजिनल रेडिओ ॲटम असेल त्याला आपण पॅरेंट ॲटम असं म्हणतो. That parent atom is transformed into a new atom by disintegration. आता ह्या parent atom जो आहे, ह्या parent atomचं disintegration झाल्यानंतर parent atomचं disintegration झाल्यानंतर जो न्यू atom तयार होतो त्याला आपण daughter atom असं म्हणतो. Right? In many cases, the daughter atom so formed from the parent atom is radioactive and disintegrate into a new daughter atom. The successive transformation leads to a long chain of different radioactive atoms ending in a non-radioactive stable element. म्हणजे हा radioactive atom जो आहे, radioactive, okay, त्याला parent atom असं म्हणतो. radioactive element चं कन्वर्जन हे लॉंग चेन नंतर म्हणजे डॉटर असेल अशी मोठी लॉंग चेन असेल त्याचं डिसइंटिग्रेशन होऊन फायनली नॉन रेडिओ इलेमेंट जो आहे तो फॉर्म होत असेल. नॉन रेडिओ इलेमेंट ओके तयार होतो. राईट, ही जी चेन आहे, ओके, this long chain of different radioactive atoms ending in a non-radioactive stable element, these different stages of integration naturally constitute of series and this is called as successive disintegration. ही जी लॉंग चेन आहे ह्या लॉंग चेन मध्ये स्टेबल नॉन रेडिओ स्टेबल इलेमेंट आपल्याला मिळतो. स्टेबल इलेमेंट, राईट, अँड धिस लॉंग चेन इज कॉल्ड ॲज द सक्सेसिव्ह disintegration. Right? Here consider radioactive substance A which decay to from a daughter substance B, which is also radioactive and it decay into C, and so on. Finally we get a stable element X. Stable element X. Then म्हणजे बघा ही कशी झाली, ए पॅरेंट रेडिओएक्टिव्ह इलेमेंट आहे, त्याचं डिसइंटिग्रेशन होऊन डॉटर इलेमेंट बी मिळाला, परत बीचं डिसइंटिग्रेशन होऊन सी हा अल्सो रेडिओएक्टिव्ह इलेमेंट आपल्याला मिळतो, आणि फायनली वी गॉट दी एक्स. एक्स हा कसा आहे, नॉन रेडिओएक्टिव्ह इलेमेंट आहे आणि तो स्टेबल आहे. राईट. ही जी चेन आहे ह्या चेनला आपण काय म्हणतो, सक्सेसिव्ह डिसइंटिग्रेशन असं म्हणतो. राईट. Successive disintegration. Must remember here we discuss the what is meant by successive disintegration. हे लक्षात आलं असेल. ओरिजिनल रेडिओएक्टिव्ह ॲटम जो असतो त्याला आपण पॅरेंट ॲटम म्हणतो. त्याच्यानंतर पॅरेंट ॲटमचं डिसइंटिग्रेशन होतं स्टार्टिंगचं, म्हणजे इथे ए हा काय झाला, पॅरेंट ॲटम झाला, पॅरेंट. ओके. आणि बी हा काय झाला, डॉटर. बी इज दी डॉटर atom. Okay, must remember here what is meant by parent and what is meant by daughter and what is the successive disintegration. Next point is the applications of radioactivity. The radioisotopes are successfully used for research in field of biology, chemistry, psychology, physics, agriculture and other sciences in addition to industry. Following are the few broad uses of radioisotopes in different fields. म्हणजे हे रेडिओआयसोटोप्स आहे, हे रेडिओआयसोटोप्स वेगवेगळ्या फील्डमध्ये, सायन्समध्ये रिसर्च सक्सेसफुली यूज फॉर रिसर्च इन फील्ड ऑफ बायोलॉजी, केमिस्ट्री, psychology, physics, agriculture and other sciences in addition to industry. There are following few broad uses of the radioisotopes in different fields. First one is the medicine science. Medicine science. Okay. First field is the medicine science, and in medicine science the radioisotope iron 59 is used to study the deficiency of red blood cell. Iron 59 is iron 59 is used to study the deficiency of red blood cell. Red blood cells in human body. In human body, right? Then pumping action of heart is situated by using sodium 24. Pumping action of heart. Here pumping action of heart is situated by using sodium 24 and iodine 131. The functioning of kidney, liver, under normal and diseased condition is situated by iodine 131. Right? Some radioisotopes are used to cure brain tumor. काही रेडिओएक्टिव्ह आयसोटोप्स जे आहे ते क्युअर ऑफ ब्रेन ट्यूमर ब्रेन ट्यूमर यासाठी पण युजफुल आहे. अँड रिलीव्ह दी पेशंट फ्रॉम दी सेव्हर हर्ट पेन. फर्दर कोबाल्ट 60 त्यासाठी कोबाल्ट 60 अँड गोल्ड 198 हे रेडिओ आयसोटोप्स जे आहे ते यूज केले जातात. ओके. फॉर ट्रीटमेंट ऑफ द कॅन्सर phosphorus 32 is used for the curing skin disease and iodine 131. म्हणजे हा गोल्ड कोबाल्ट 60 असेल, कोबाल्ट 60 अँड गोल्ड 198 हे कॅन्सर ट्रीटमेंटसाठी यूज केले जातात. ओके. आणि फॉस्फरस 32 is used for the curing skin diseases. And iodine 131 is used for the treatment of the thyroid glands. थायरॉइड ग्लँड्स जे आहे, थायरॉइड ग्लँड्स त्याच्यासाठी त्याच्या ट्रीटमेंटसाठी हा आयोडीन 131 यूज केला जातो. these are the medicine science applications of the radioactivity in medicine science. In medicine sciences, the radioisotopes iron 59 is used to study of the deficiency of red blood cells in human body. Pumping action of heart, sodium 24 and iodine 131 is used. The functioning of kidney, liver, iodine 131 is used. Cure brain tumor, cobalt 60 is used, and cobalt 60 and gold 98 are the use for the treatment of the cancer. Treatment of the cancer. Okay. Then phosphorus 32 is used to the skin diseases, and iodine 131 is the used to treatment on the thyroid glands. These are the different applications of the radioactivity in a medicine science. Okay. The next one in agriculture. In agriculture field, there are several applications of the radioactive substance. These are in first applications of the radioactivity we already discussed in medicine science, and second one in agriculture. In agriculture, the radioisotopes are used to study the functions of fertilizers. Functions of fertilizers for different plants. They have also used for the developing new species of plants by causing the genetic mutation. Developing new species of plant by causing genetic mutation. This is the use for the radioactivity in a agriculture field. Okay. Functions of the fertilizer for different plants and developing a new species of the plant by causing genetic mutation. Third application in an industrial field. Okay. The radioisotopes are used to study the wear and tear of the pistons, ring of gears in engines, and then in the study of the suitable lubricant for their preventions. They have been used to study the underlying earth layer during oil exploration operations. They are also used to detect flow in metal structure and for different treatment of alloy such as quenching, annealing and case of hardening. They are used for the uniform of lubricant and greases. Okay, these are the applications of the radioactivity in medicine science, agriculture and industry. And fourth one is the in nuclear research. In nuclear research, radioisotopes have been used in the study of nuclear disintegrations element. म्हणजे न्यूक्लियर रिसर्च मध्ये हे रेडिओआयसोटोप्स जे आहे हे रेडिओआयसोटोप्स have been used in the study of nuclear disintegration of elements. Nuclear disintegration elements, right? And fifth one is the food preservation. Food preservation by exposing the vegetables and other food stuffs to radiations from the radioisotopes, their shelf life can be increased. Okay, म्हणजे इन फूड प्रिझर्वेशन साठी सुद्धा हे रेडिओएक्टिव्ह सबस्टन्स जे आहे ते युजफुल आहे. आणि लास्ट फील्ड जी आहे इन रेडिओएक्टिव्ह डेटिंग. C14 have been used for the dating of the cultural history or for estimating the age of some geological formation. म्हणजे cultural C14 has been used for the dating of the cultural history or for the estimating the age of some geological formations. These are the different field for the radioisotopes are used. First field is the medicine science, in agriculture, in industry, in nuclear research, in food preservation, and sixth one is the in radioactive dating. Okay, these are the different applications in a different field of these radioisotopes. That means in today's lecture we successfully discussed the successive disintegration. After that we discussed the specific activity, then we discuss this successive disintegration, and then we discuss the some applications of the radioisotopes in different field. Okay, must remember these are the very important in a nuclear physics. Okay, today we stop here. Thank you very much.